Welcome again. So in continuation with the previous two lectures where we have discussed the theoretical aspect of break-even analysis and we have seen how we can manipulate the break-even point, let us see some of the problems, how we can utilize these two concepts to solve the problems. So let us see a problem, a very simple problem. So the problem is like this: a product currently sells for $12 per unit. The variable costs are given as $4 per unit and 10,000 units are sold annually and a profit of $30,000 is realized per year. So this is the data given. So what data is given? The selling price is given as $12 per unit. The variable cost is given as $4. So variable cost is given as $4. Units sold 10,000 per year. Units sold 10,000 per year. So this is also given. So units sold 10,000 per year, and the profit margin is given as 30,000. So a profit margin is given as 30,000. So whatever information is given is listed here. Again, a new design will increase the variable cost by 20% and fixed cost by 10%, but the sales will increase to 12,000 units per year. So again, I have written this information on the solution slide. So this is the new design information regarding new design. A new design will increase the variable cost by 20% and fixed cost by 10%, but sales will increase to 12,000 units per year. So whatever is given in the question, that is being replicated here. So what is being asked? At what selling price do we break even? So that is part 1. If the selling price is to be kept same, that is $12 per unit, what will the annual profit be? So let us see how we can apply what we have discussed while solving this problem. So these are the input information which is given. So if we just apply the fundamental, that is the profit is nothing but it is revenue minus cost. So profit, since profit is given, so profit, if we just replace these with the numerical values, so profit is given as 30,000. Now total revenue generated, how we can compute this? The total number of units sold multiplied by the selling price. So this will be 10,000 multiplied by 12, that is written here, minus the total cost. Again, that these costs will be composed of two components. One is the fixed cost and second one is the variable cost. So variable cost is given as $4 per unit. So it will be 10,000 into $4, and there is no mention of fixed costs. So leave this fixed cost as it is, and if we just solve this, so we can compute annually what will be the fixed cost. So the fixed cost associated with this data, this comes out to be $50,000. So this is what we can compute from this given information. Now what is being asked, that if a new design is being implemented, what will be the selling price at which the break-even point occurs? So if we just see the information with the new design, so the new design will increase the variable cost by 20%. So the new variable cost, it will be 1.2 times of the variable cost earlier. So the variable cost earlier is $4. So it will be $4 into 1.2. So for the new design, the variable cost will be $4.8 per unit, and the fixed cost by 10%. So the fixed cost will increase by 10%. So earlier what we are getting as fixed cost is $50,000. So increase by 10%. So we multiplied by 1.1. So now the fixed cost will be $55,000. Say X be the break-even selling price. And again, if we just use this particular equation, so if the selling price is X, so profit, so the number of units sales will increase to 12,000 units. So the amount of revenue generated by selling 12,000 units, it will be 12,000 multiplied by X plus this will be equal to the revenue generated. So the revenue generated will be, so this will be the profit, and the fixed cost, fixed cost. So the fixed cost will be $55,000 and the variable cost will be, so at break-even point, what do we have? We have the total revenue equal to total cost. So there is no profit. So if we just put this profit zero, it is zero. That means revenue will be equal to cost, because at what selling price break-even occurs, it is being asked. So there is no profit, rather revenue will be equal to cost. So the total revenue generated will be equal to 12,000 multiplied by X. This will be equal to total cost. So total cost is given as 50. It will be composed of two things: the fixed cost. So fixed cost is 55,000 for the new design, and the variable cost is this much. If we just solve for X, it comes out to be $9.38. So this will be the price of the unit to be charged, so that a break-even point will be achieved at this much amount of production or this much amount of selling. Now in part B, if the selling price is to be kept same, that is 12 unit, what will be the annual profit be? Now again, profit is revenue minus cost. So again, for 12,000 units are to be sold, the selling price is same, there is no increase. So the total revenue generated will be 12,000 multiplied by 12 minus the costs. So again, there are two costs. One is the variable cost and the fixed cost. So this is the fixed cost and this is the variable cost. If we solve this, the profit comes out to be $31,400. So this is how we use break-even analysis to compute the relationship between all these costs: selling price, variable cost, units sold, profit, revenue. So this is all about today's video lecture. Thank you very much. So this is all about how we can use this break-even analysis for decision making. Hope you have enjoyed these 3 lectures on break-even analysis, and let's meet again in some more lectures where we will be discussing about the benefit cost ratio, the depreciation, and many other topics related to engineering economy. Thank you very much. Have a pleasant day.